Welcome to the DIY Honda Garage channel. This presentation covers the DTC or Diagnostic Trouble Code P2243, which refers to a high voltage condition detected in the VCENT circuit associated with the air-fuel AF sensor 1 in Honda Civic models from 2016 to 2021. The VCENT circuit is important for proper sensor operation, including the regulation of the fuel mixture based on the air-fuel ratio. If there's an issue in this circuit, it can lead to engine performance problems and increased emissions due to incorrect readings from the AF sensor. The AF sensor 1 is typically located upstream of the catalytic converter in the exhaust stream, making it crucial to monitor for efficient combustion. This detailed troubleshooting guide will help identify and rectify the issue related to this specific DTC effectively. DTC P2243 signifies a high voltage signal in the VCENT circuit associated with the AF sensor 1. This sensor is pivotal in measuring the air-fuel mixture present in the engine's exhaust system. Primarily located upstream of the catalytic converter, the sensor assists the engine control module ECM in making necessary adjustments to optimize fuel efficiency and reduce emissions. If this sensor fails, the engine may run too rich or too lean, leading to poor performance and possibly triggering the check engine light. Understanding the exact characteristics of this error is crucial, as resolving it requires clear identification of the affected components and circuit paths involved. It's recommended to carefully check the AF sensor and its corresponding wiring for any faults that might lead to this high voltage reading. The possible causes for DTC P2243 include several key factors that can affect the functionality of the AF sensor 1 and the VCENT circuit. An open circuit in the VCENT wire can disrupt the signal, leading to high voltage readings being reported. Additionally, a faulty AF sensor itself may give inaccurate readings because of internal defects or degradation over time. Another potential cause is related to the powertrain control module PCM, where internal circuit issues may prevent proper signal processing. Understanding these factors allows diagnostic technicians to focus their troubleshooting efforts effectively, starting with the simplest potential causes before exploring more complex issues. If the cause is not found quickly, it can lead to further complications in engine performance and increased emissions. When DTC P2243 is present, there are several symptoms that the driver might notice. The check engine light is likely to be illuminated on the dashboard, indicating a fault in the engine management system. Drivers may also experience poor engine performance, which could manifest as hesitation during acceleration or difficulty maintaining speed. Additionally, the presence of this DTC may lead to increased emissions as the engine struggles to maintain an optimal air-fuel mixture. These symptoms are crucial indicators that can guide technicians in identifying the issue accurately and promptly. Addressing this DTC swiftly is essential not only for maintaining engine performance, but also for complying with emissions regulations. In the first troubleshooting step for DTC P2243, the technician must verify the problem while the vehicle is running. Begin by turning the vehicle to the on mode and using the HDS or Honda Diagnostic system to clear the existing DTC. After clearing the DTC, start the engine and hold the engine speed at 3000 RPM without any load, which means the continuously variable transmission, CVT, should be in P or N, or manual transmission, MT, in neutral. Monitor the vehicle until the radiator fan engages and then allow it to idle. This process allows the technician to check for pending or confirmed DTCs using the HDS again. If DTC P2243 reappears, the issue is duplicated, and the technician should proceed to the next troubleshooting step. If it does not reappear, intermittent failures may be present, and further inspection of the connections and terminals is necessary. The second troubleshooting step involves checking the VCENT line for continuity to ensure that the circuit is not open. Begin by turning the vehicle to the off or lock mode. Next, jump the SCS line with the HDS and wait for more than 1 minute. Then, disconnect both the PCM connector E, ADP, and the AF sensor, sensor 1, 6P connector. This step is critical, as it requires checking for continuity between specified test points. Test point 1 is the female terminal number 4 of the AF sensor 6P connector, and test point 2 is the PCM connector E, ADP, number 74. If continuity exists, this suggests the VCENT wire is functioning correctly, allowing you to proceed to the next step. However, if there is no continuity, it indicates an open circuit that needs repair between the PCM and the AF sensor, which could resolve the high voltage issue. In the third troubleshooting step, a critical evaluation of the PCM is necessary to determine if it is functioning correctly. Begin by reconnecting the PCM connector E, ADP, and exiting SCS mode using the HDS. Then start the engine again and hold it at 3000 RPM, ensuring that the AF sensor, sensor 1, 6P connector remains disconnected. Measure the voltage at the designated test points while the engine is running, specifically between the female terminal 4 of the AF sensor's 6P connector and body ground. Here, the expectation is to see a voltage reading of about 0.2 volts or less. If this condition is met, it suggests that there may be no problem with the PCM circuitry, and the next step is to check for any authorized service information related to this DTC, or consider substituting the PCM with a known good unit. Conversely, if the voltage reading is higher than expected, it indicates that the PCM may be faulty, which requires the replacement of the AF sensor, sensor 1, to resolve the issue. Final repair verification after addressing DTC P2243 involves ensuring the issue has been fully resolved. After completing the necessary repairs, clear the DTC once again using the HDS and retest the vehicle to confirm that the engine operates normally without reoccurring error codes. Additionally, check that the engine runs smoothly and that there are no warning lights illuminated on the dashboard. This verification step is crucial because it not only ensures that the specific DTC has been properly addressed, but also confirms the overall health of the engine management system. The verification process helps in building confidence that the repairs made were effective and that the vehicle is now functioning as intended. Preventive maintenance strategies can be helpful in avoiding the recurrence of DTC P2243 and related issues. Regular inspections of the AF sensor should be conducted, paying attention to any signs of wear or damage that could compromise its functionality. Additionally, routine checks of wiring connections related to the AF sensor and PCM can help prevent issues caused by corrosion or loose terminals. It's also beneficial to stay up to date with any Toyota software updates for the PCM, as these can often resolve systemic issues related to sensor readings and improve overall vehicle performance. Such proactive measures can help maintain optimal engine efficiency and reduce the risk of similar DTC occurrences in the future. In conclusion, DTC P2243 is an important diagnostic trouble code, indicating a high voltage condition in the VCENT circuit of the AF sensor 1. The troubleshooting process requires careful verification and methodical checks of the associated wiring, the sensor itself, and the PCM's internal circuitry. Each troubleshooting step builds on the previous findings, allowing for an organized approach to pinpointing the issue accurately. The potential repercussions of this DTC can impact vehicle performance and emissions, emphasizing the need for thorough and timely repairs. Ultimately, regular maintenance practices will help prevent similar diagnostic issues from reoccurring, contributing to the longevity and reliability of the Honda Civic. Please like and subscribe to the channel. See you next time!